Jones, good stuff. Interesting. Interesting discussion. Here's the problem. Epistemology is not nearly so simple as to be encompassed by a Venn diagram. And I'm sure you're well aware of this. These are just the generalities the general concessions that we make towards simplicity for the sake of moving the argument along. But I do have to say that since we have gotten into epistemic territory, that we've got some problems, because there is no real substantial agreement, and in point of fact, disagreement on these issues is one of the defining conflicts of epistemology in particular, and philosophy in general. Questions of what actually constitutes justification, what actually constitutes truth, what actually constitutes knowledge, and kind of the dark horse candidate, the dark horse in epistemology. How do we come to believe things? This is part of the problem. First, there is immediate applicability of recursion to this process, given this definition for truth and knowledge, belief, justification, and their relations. There's immediate recursion that is applied. That being, justification is reliant on a specific set of assessment criteria. We might say, for example, that when we find a proposition to be logically consistent, that we can say that it is justified. That proposition itself is a knowledge claim or a truth claim. And how do we validate it? Well, much of the time, we validate it according to other proposed justification systems. Anything from demonstrability, observability, to utility. We need to ignore problem X in order to bring about outcome Y. This is applicable to all of the fields in this Venn diagram. The question of what constitutes truth is obviously, and you're well aware of this, obviously far too complicated, far too immense a series of questions and a series of arguments to simply take a blank assertion of a definition for truth a priori. That's not even entirely the problem. The vagaries and ambiguities of epistemology are certainly beyond the scope of a video reply, or for that matter, the entirety of a video channel, or for that matter, if every YouTuber committed themselves full-time to discussing this exclusively and made a commitment to non-repetition, so none of us were aping each other, we would still be cranking away for a very, very long time before we had even covered all of the ground that has already been covered. So, that aside, these definitions, these propositions are far more complicated than any proposition that would allow us to simply take them at a stroke. But that statement itself is a truth proposition with systems of justification implied, and with fairly complicated relationships regarding this proposition and belief also implied. So let's set that aside for the moment, and a couple of quick examples in the context of the example that you're using here. 2 + 2 = 4. Belief, knowledge, truth, and justification in this. Let us say from my own perspective, I will say that given 2 plus equals and 4, given that these are intrinsically defined, that meaning that the definition of 2 is derived exclusively from an arbitrary proposition for 2, that this also applies to plus, equals, and 4, and that these definitions are not contextual but are consistent. That I can say that 2 plus 2 equals 4 is a valid expression. Part of the problem there is that that definition does not necessarily have the totality necessary to make that an exclusive proposition. So, I can say from my definition of how 2 behaves and what makes 2 2, that this is a valid expression. Unfortunately, the definition of 2 is not so all-encompassing as to allow me to say that 2 exclusively behaves in this way. There is no proposition intrinsic to the number 2 that indicates that 2 has no exceptions to the way that it operates, has no possibility for divergence from this normal operation of 2. For that definition, we have to go to an overarching system which oversees all of these definitions, arithmetic, which would tell us that no, 2 is always 2. But even there, even there, this proposition has to be asserted and then assessed. Mathematics relies to a great degree on us not asking that sort of question, and for itself, for the syntactical game that it proposes, bearing in mind that it is a game that brooks no cheating, it works just fine. It works just fine. The real problem comes in when we infer that we are referring to something outside of mathematics. Let's say that you and I are having a conversation on the difficulty of herding squid pigs. Now, neither you nor I are particularly knowledgeable about squid pigs. The behavior of squid pigs and the properties of squid pigs are something that neither of us feel in our personal valuation of our own understanding, that neither of us are particularly qualified. And again, even that statement, qualification, we've got all sorts of questions that ride along in the cart. But let's say, squid pigs. We can say, let's say we're having this conversation, and I say, well, we have 2 squid pigs over there, we have 2 squid pigs over there, and we are going to put them together. And 2 plus 2 equals 4. At that point, I am no longer talking exclusively about the rules of mathematics. At that point, I have inferred that I am symbolically referencing these 2 squid pigs with the 2 in this operation and expression, and that this process of herding them together is represented by the plus. At that point, the specific properties of squid pigs in squid pig herding assert themselves over the proposition of this expression. And that's where we come into the real problem, because when it comes to the properties of squid pigs, of which we are both ignorant, and how those properties may interfere with the proposition that 2 plus 2 equals 4, we don't know. We just don't know. We can't know that 2 plus 2 equals 4 is a valid proposition when we are talking about squid pigs. So, it gets pretty interesting pretty fast.